Okay. What if you have three variables? Then what we're looking for is really what's called an ordered triple. It looks like a coordinate, but it's three-dimensional. So it's got X, Y, and Z. And yes, there are three-dimensional graphs and, computers that do that kind of stuff. And we're not dealing with lines anymore. These things right here are all planes. It's like an unending sheet of paper or a wall that goes on forever and ever and ever. Now, if you take three planes and you intersect them, like you can look in the room that you're in right now. You can look up in the corner. You can see the intersection of two planes. The intersection of two planes is right in the crack where the corner comes together along the walls. But if you intersect the ceiling and two walls, they come together in a point up in the corner. And so what we're actually going to find is the location where the three planes come together. Where do the three planes come together? So we're going to find that location. And that's an ordered triple, and we would have, and yes, if they use different letters, put them in alphabetical order. If it's ABC or RST, but I will try, we'll hopefully math teachers are smart enough to just use XYZ so we don't, make it all difficult. All right, let's see what we're going to do here. I need you to focus your attention on one variable, and I really think that if you pay attention to what I'm about to do, I will save you a lot of trouble. So I am looking for a situation that it's easier from other situations. Now, I particularly think that there's one choice here that is the easiest, but none of the choices are really that bad. I'm going to focus my attention on the y's. That's where I'm going to focus my attention. I see that we have some small numbers, and I think it is going to be very easy to change the middle equation. And that's the only one I'm going to change is the middle equation. I like the fact that the top and the bottom are the same, and that the middle one is opposite. That's the most ideal situation. So, what am I going to multiply this middle one by? I'm going to multiply by 2. And so, that changes that middle equation to 2x minus 2y minus 2z equals 6. X plus 2y. I'm not changing the top equation. I'm not changing the bottom equation either. So I just multiplied the middle by 2. So that this situation would occur. This is what I was hoping for. Top and bottom are the same, middle one's the opposite. What we want to do is we want to pair up the top one and the middle one and add them together. And so if we do that, we would have 3x, the y's would cancel out like we wanted, and a plus 2z, and 6 plus 6 is 12. And now I want to focus on the middle one and the bottom one and add them together. 7x, y's cancel out, minus 1z, and 6 plus 5 is 11. Now I'm to this point. So we want to keep this strategy going. I think it looks like the z's would be a good one to eliminate. So I'm going to multiply this equation by 2. Here, I'm just going to write this below. 14x minus 2z equals 22. And then we can add this and this together, which would give us 17x equals 34. Because the z's cancel. And then we can divide by 17 on both sides, and we get an x value of 2. All right, well, what do we do with that? How do we find another variable? Well, basically, you're going to go back to one of these equations, pick which one is your favorite. Let's pick the top one. And although if you really like the bottom one, you're more than welcome to use that. Subtract 6. 2z equals 6. Divide by 2, and now we know that z is 3. Now remember, we said that the final answer would be an ordered triple. Well, we just found out that the x value is 2, and the z value is 3. You might as well go ahead and put the final 2 parts in there. I still don't know what y is. How am I going to figure that out? Oh, go back to the beginning. Pick one of your equations from the beginning. You can pick that one right there. In fact, you can pick any of these equations. Obviously, some of them are just duplicates, but any of those would work. So if I use the top equation right there, that's 2 plus 2y plus 4 times 3 equals 6. Obviously, that's 2 plus 12, which makes 14. To get the 14 to the other side, we're going to subtract it. And then we divide out the 2. And we get a y value of -4. So now we know the last piece of the puzzle. So, where do the 3 planes come together? At the coordinate 2, -4, 3. Bet you didn't know that Desmos had a 3D grapher. So, let's see what it looks like when we plot 2, comma, -4, comma, 3. Now, it might be hard to really tell that. So let me do this like one step at a time. Let's suppose it was 2, 0, 0. Okay? So you can see that it went over 2 on the x-axis. Well, then what if I then went -4? So it's over 2 on the x-axis and back 4 on the y-axis. So for us, that's like right and down. And then lastly, it's going to be 3. This is the part that's hard for us to visualize. It's going to come up 3 units. So as I go to change this, it jumps up 3 units, so it comes off of the xy plane. And you could see, and maybe I should have done that from the very beginning, you know, to show you what's going on here. Don't stop spinning. Got to show these kids what's going on. So, try that again. I got a 0, 0. You can see that that is just on the x-axis only. Okay. But then when I go -4, all right, now you can see that it's moved off the x-axis down 4. And then lastly, up 3, you can see that it's jumped off the xy axis. It's now 3 units above So that's what it looks like. Now, could we have graphed all three planes and had it find the I don't know. But you're not going to be able to use Desmos 3D Grapher for testing. So you can't get used to it. You've got to do, this is an algebra class. Okay? You got to learn how to do algebra. Okay, so how do you check to see if you're right? You can substitute the x, the y, and the z values into the three original equations of the system and check to see that each of the equations are true. So in that last example, we could literally plug in 2, -4, and 3 for each x, y, and z and find out if we do indeed get those values, which we would, but it has to be true. Now, substitution. We're going to use substitution on this question. So let's see how we do this one. I can see that one of the equations is solved for a single variable, or not, it's solved for x. So I'm going to use that and rewrite this second equation. 2 times 3y minus z plus 6 minus 5y minus z equals -2. Something tells me this is going to be really long and drawn out. And you guys are going to complain about it. Plus y plus 2z equals 7. So I just replaced x in both of the second equation and the third equation. All right. So now we're going to start all of this simplification process, right, as best we can. And I'm probably going to stack things. So I've got 6y minus 2z plus 12. And then I have another -5y and a -z. Okay, and on the other side equals -2. So just that equation right there alone is going to be 1y minus 3z. And then I'm going to take that 12 and move it to the other side, so it's equal to -14. We ended up subtracting 12 to the other side. Whew, man. I'll show my work down here, and then I'll have two equations to solve here in a second. So let's see here. Distribute, distribute, distribute. That would be -3y plus z minus 6. And then we have plus 1y plus 2z. And all of that equal to 7. And so that would be -2y. This would be positive 3z. And oh look, that gets moved to the other side, adding 6. So we have -2y plus 3z equals 13. Okay. That was kind of brutal. So now we can start adding things together. Now, how do I know I can add them together? Because I see those things are going to cancel out when I do add them together. If that weren't the case, then I'd have to do some multiplying like we did in the last lesson. But add them together and I get -y equals -1. If you divide by -1 on both sides, you get y equals +1. So now we know in our final answer, something, comma, something, comma, something, we know that there's a 1 in the middle. All right. Where do I go? What do I do? Pick one of your favorite equations up here, plug it in. Really doesn't matter to me, so I'll pick that one right there. 1 minus 3z equals -14. So we're going to subtract 1 to the other side. -3z equals -15. And we're going to divide out the -3. So now we know that Z is positive 5. So put it in our answer. Z comes after Y, so now we're going to go back to the beginning, right? We're going to find out what X is because we're going to use that first equation. 3 times Y. 3 times Y. Y was 1. Okay. Minus 5 plus 6. So we're just using this equation right here. And so 3 minus 5 is negative 2, and negative 2 plus 6 is 4. So we found the last piece of our puzzle. 415. Let's go to the next one. All right, we got a vending machine takes change in only nickels, dimes, and quarters. There are 40 coins. Well, right there's an equation. Like if we call the nickels, the dimes, and then the quarters, so x, y, z, we can say x plus y plus z equals 40. And it says that the value of the coins is $5.30. So yes, we would use the concept of, let's see here, let me shrink this down. We would do 0.05 x plus 0.1 y plus 0.25 z. I'm gonna put the equals on the other side. I didn't leave myself enough room. Dang it. Maybe I should try this again. I wonder if I could just type that one out quickly. That would be nicer. 0.05 x plus 0.1 y plus 0.25 z equals 5.30. Okay, so there's my my equation, and not the form that I wanted in. So just like we've done before, we're gonna multiply it by 100. Okay, and so that's gonna create 5x plus 10y plus 25z equals 530. Okay? But that's not my last equation. I need one more equation. There are twice as many dimes as quarters. Now, I have instructed you in class, you gotta find the smaller group. That means the quarters is the smaller group. And we're gonna do something to the smaller group, right? So we're gonna take the quarters, which is the z, we're gonna double it, and we're gonna get the dimes. Okay? You gotta take the smaller, do something to it to get the larger. Otherwise, you're going to screw that up and write 2y equals z. You're going to substitute it wrong. Yes, this is a substitution question. Hopefully, it's going to be way easier than the last substitution question, right? So the 2z is going to go in place of the y's. So my first equation has x plus 2z plus 1z equals 40. And my second equation has 5x plus 10 times 2z plus 25z equals 530. So, need to simplify these equations down a little bit. We should use a different color here. So this one would be x plus 3z equals 40. This one would be 5x plus, let's see, that's 20z plus 25z is 45z equals 530. Well, I'm hoping you see that the x's would be the easy ones to get rid of. So we're going to multiply this by -5, creating -5x minus 15z equals -200, and 5x plus 45z equals 530. And now we can add these equations together because, as you can see, those things are going to cancel out. That's what we wanted. And so if I add them together, I'm getting 30z equals 330. And then, of course, we can divide by 30 on both sides and get z equals 11. So now we know we have, so let's see here. Nickels, dimes, and quarters. We know we have 11 quarters. Well, what are we going to do to find out any of the other ones? Plug it back in? Sure. Pick an equation that you'd like to plug it back into. I actually have a couple options here. I could take it all the way back over to here. That would be the easiest one. Now, yeah, you could pick this equation, you could pick this equation, but it's not, neither one of those is the easiest. That one back there at the beginning is the easiest. But it's up to you what you want to do. So 2 times 11 equals y, so that's 22. So now we know that we have 22 dimes, right? Well, doesn't that make it really easy to then go back to the very beginning? The very first equation is the easiest one in the world to use for the rest of this. X plus 22 plus 11 equals 40. Of course, that's 33, and we're going to subtract 33 to the other side, getting rid of the 11 and the 22. So now we know that we have 7 nickels. So 7 nickels, 22 dimes, 11 quarters. But that's how I solved that one. All right, let's go to the next one. Well, I guess that was my last example. I thought I had one more, but I don't. So, on to the homework. See you next time.